Hello student. Yesterday we covered a topic fundamental theorem of arithmetic. Now we solve some more question based on fundamental theorem of arithmetic. Now we see one more question here. Check whether 6 to the power n can be AND with the digit 0 for any natural number n. That means we have to show that the unit digit of 6 to the power n is 0 for any natural number n. Now all we know that if 0 is unit digit of any number, that means that number is divisible by 10. If any number is divisible by 10, that means it is divisible by 2 and 5, because the prime factorization of 10 is 2 into 5. Now we write it first. If any number ends with the digit 0, it should be divisible by 10, or in other words it will also be divisible by 2 and 5, as 10 is equals to 2 into 5. But we all know the prime factorization of 6 is 2 into 3. So we can write prime factorization of 6 to the power n is equals to 2 into 3 whole to the power n. Prime factorization of 6 to the power n is equals to 2 into 3 whole to the power n. In the prime factorization of 6 to the power n, 5 is not there. That means 5 is not a prime factorization of 6 to the power n. It means 6 to the power n is not divisible by 5. So similarly 6 to the power n is not divisible by 10. That means it cannot be AND with the digit 0 for any natural number. It can be observed that 5 is not in the prime factorization of 6 to the power n. Hence, for any value of n, 6 to the power n will not be divisible by 5. So 6 to the power n cannot be AND with the digit 0 for any natural number. So by using fundamental theorem, you can solve more questions like this by using prime factorization. Now we are going to solve another question. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. Now we take first number, after that second. Now we have to prove that that number is a composite number. All we know that number are two types, either they are prime numbers or composite numbers. Prime numbers having only two factors and composite numbers having more than two factors. Now we have to prove that that number having more than two factors. Now we see that 13 and 13. 13 both are common here. So we take common outside the bracket. Now 7 into 11 plus, what is remaining here? 1 is remaining here, because the 1 is the multiple of every number. So 1 is remaining here. Now 13 it will become 77 plus 1. Now 13 into 78. We know that 13 is a prime number and 78 is a composite number. So we can write 78 as a multiple of 13 into 6. Otherwise we can also write as it is, no problem. Into 6, or we can write 6 as a 2 into 3. Whenever a number can be written as in the product of prime number, then that number is a composite number. It means the number is a composite number, or in another word we can say that when that number having more than 2 factors, so it is a composite number. Number having more than 2 factors, so it is a composite number. Next number is 7 into 6 into 5 into 4 into 3 into 2 into 1 into 1 plus 5. Here we can see that 5 and 5 both are common here, so we can take 5 as a common. 7 into 6 into 4 into 3 into 2 into 1 plus 1. 5 into 7 into 6. 1008 plus 1. 5 into 1009. Both are prime numbers. That means that number having more than 2 factors, so it is also a composite number. Hence 7 into 6 to 4, 5 into 4 into 3 into 2 into 1 plus 5 is a composite number. Is a composite number. Hence proved. In both questions we proved.